So once again we'll come up to the side, re-zero our compound, come up to the side till we touch off, lock our carriage, travel along 11.5 millimeters. Okay, that's 11.5. We should have approximately 6 mil side. Just a sanity check, we'll do with the ruler. Yeah, that's fine. Okay, so we zero our cross slide dial. Get our coolant back on and repeat the process. Just a little bit more coolant. Okay. This is one job I really wished I had a DRO on this machine instead of twatting about with knobs and dials. It will come one day. Okay, let's go for it. The third groove. Just making sure we got clearance between the tool and the jaw of the chuck and the edge of the tool. So we've got about 2 millimeters, so that'll be fine. Okay. Just adjust you up a bit. We'll have a look at that. So the grooves all came out well. That tool left a really nice finish on this aluminium. So we'll get set up now to cut the angles. So our A-section pulley has an included angle of 34 degrees that we have to cut. So it means I've got to swing the compound around to 17 degrees, and as per usual it goes out of the degree scale, so we're back to using the angle protractor. So just a stack of parallels that are hard up against the cross slide, and makes it easy to set the angle protractor square parallel with the universe and set our angle. When I ground our grooving tool up that we did the 3 grooves in, I ground it perpendicular to the shank of the tool, so when I go to move my compound or reset this tool up any time, I only have to touch off this face of the tool, square it off against the front face of the job, which makes setting the tool very easy. There's nothing really to set. You can just wind the shank of the tool up against the front of the job and tighten down the tool post. So we're going to use the same tool to cut our angles. So what that means, when we'll start cutting the bevels down one side only, and we'll stop just shy of hitting the bottom there. Right, I'm just going to put some layout lines on this just to mark where our groove starts and finishes. Okay, with the tool on centre, we're just going to use an indicator and travel, worked it out to 3.63 millimeters. We have to come across, so we got 1, 2, 3.63 is there. Okay, if we plunge directly in there, that's our first mark. Okay, so I can quite merrily chomp away the unblued section, and we should blend in down the bottom of the groove there. So we'll do that to all three. We'll just do one at a time. Okay, that's looking pretty good. I'll just get a measurement check from this face here across to the edge of our groove. So our finished dimension from this corner to the very corner there should be 357 thou or 9.06 millimeters. So we're pretty well there. We'll just take a couple of thou, just a smidgen cleaning cut, and we'll call this face done. I was going to rough these out and then go back to them, but I'll stick with this method because it's coming out to size. So just put a bit of WD on it and take a light cleaning cut, and that's that one done. Zero. That's it. That's the ticket. Okay. That's pretty hard to get a 9.05 as close as I can pick up. 356 milli, 356 thou. And we want 357, so that's close enough for a pulley. You can get a bit of, I'm only just trying to pick up the very corners there with the caliper, so you can be a couple of thou either way, it doesn't really matter a great deal. On the width of a pulley, there's on an A section pulley, your minimum is 0.494 thou, and your maximum is 504 thou, which is the total width. So we're well within that range. So we'll carry on and complete the other two. Okay, so once again we zero our tool in the slot. We're aligned there. We do a shift that way towards the tailstock of 3.63 millimeters. 1, 2, 3.63. There. Okay, we'll just start the lathe up and get our line marked. And as before, once we've cut this complete piece away, we should have a blend in the bottom corner as we did with this one here. Okay, I'll get a dimension check on that one. What do we want? Millimeters and 9.06. That's pretty close there. That's close enough. Okay, one to go on this side. Okay, so once again we repeat the process. We zero our tool in the slot, make a shift across with the saddle, 3.63 millimeters. 1, 2, 3.63, right there. Okay, quick measure. And we're there. Okay, so what I'll do now, I'll swing the compound slide around the opposite way and we'll cut the 3 remaining grooves on the opposite side. Okay, so to cut our bevels or our angles on the other side of the 3 grooves, all we have to do is our same tool, just come up, touch off against this face and then traverse the tool across 3.63 millimeters. Just wind in till we get a witness mark on our face here, on the OD, and when we've cut up to that mark we should have a good blend at the bottom of the groove there, and we should also end up at the correct width of 1/2 inch or 12.7 millimeters. Okay, we've just marked our position to cut where to cut up to on our last groove. We have a bit of a problem here as the jaws will hit the tool. So what I've done, I've just wound the tool in by hand, just pulled it around until that jaw there makes contact with the tool. So at least I've got a mark. So what I'm going to have to do is pull this tool out and put something different in, just to give me that bit of added clearance there. So let me go and find something. That's a bit of a cock up, well, more of a pain in the ass. We'll get round it. Okay, that's got that problem solved, so we can continue. So that worked out pretty good with a bit of help from our buddy the tool and cutter grinder. We were just able to grind a bit of clearance in the tool just to clear our jaw. So that enabled us to get the cut completed, and we didn't lose any of our settings. So Aaron, that board you gave us, the whiteboard for scribbling things on, it's really come in handy in the shop. Cheers, mate. So that's from Aaron at Aaron Engineering. Has a small channel going, so it's quite a laugh sometimes, so go and check him out, Aaron Engineering. And of course, new month, new calendar girl. Can't have a shop without a calendar girl. So now we have to bore the pulley out to a 3/4 diameter to fit the motor shaft and broach a keyway through. So I'm just going to put a 17mm drill through, get our coolant running, always battle with these plastic flexible hoses. Now, be on the lookout for a couple of the steel flexible ones. And we're through. So we'll get a boring bar set up now and get this bored out to 3/4 of an inch. I actually do have this 3/4 diameter chucking reamer. As you can see, hold it up close. She's not the greatest finished tool in the world. It's Chinese, and I don't actually trust it. I've never used it. I don't trust it to do this bore. I did intend to do a trial bore on a piece of material with this reamer just to see what size it's actually cutting. So for this job here, I'm just going to do it with a boring bar until I confirm that this thing will actually cut right on 3/4. Okay, we've got about 45 thou to come out approximately, so let's put a 10 thou cut on. It'll take 20 thou off the diameter. We'll see how this bar's going to go. So we'll run the lathe on 650 RPM with a 4 thou feed rate, which is about 0.1 millimetre. Here goes. Yeah, it's a bit how you're going. Not real impressed with that. So what I'll do, the next cut, we'll slow the speed down to, next slowest is 420 RPM. We'll stick with the same feed rate. We'll see how we go. So a quick measure before the next cut. And we got 23, say 24. 24th thou to go. Okay, so I'm going to take a 9th thou depth of cut. I'll take 18 off the diameter. Just leave us about 6 thou-ish to clean up for a finished cut. Alright. Okay, slowing the lathe down has given us the improvement that we needed on our finish. So we'll get a measurement, see how we're travelling. Okay, so we have our electric motor here, old Australian made Brook Crompton Betts, made in 1997. So we need to get a shaft size. That's 3/4 of a thou under 3/4 of an inch. Thou under. Half a thou, thou under, half a thou under, thou under. So it's between half a thou and a thou under. It's an old motor, so it's a very minor wear on the shaft. So the other thing we want to check too is our broaching guide when we do the keyway. So that's a thou, 1.5 thou under. Or 1 1/4 thou under, sorry. So if we're a hair under 3/4, we should be okay. So if we're like 1/4 of a thou down on size on 3/4, we should be okay. If we made the pulley half a thou under, we'd struggle to get it on, because that would be a size for size fit on the end of the shaft. We'll see how close we can get it. Okay, so we'll dispense with the vernier, we'll go for the telescopic. We've got 7.5 seven and a half thou to come out. Feels nice and parallel too. Okay. Back in gear. Going to pull up there and check that. That's cutting a couple of tenths over 3/4. I'm just going to back this off. It'll still be alright. Roll with that and see how it goes. Take another measurement. According to this, we have 1.5, 1 3/4 thou to come out. dead parallel. 1.5 to 1 3/4 thou to come out. So what we'll do, we'll just go 1/2 thou on the cross slide. Run the cut through again. If you've got to do a spring cut when you're boring, always keep boring in the same direction. Never reverse your feed and take your spring cut going back out, because if you've got wear in the lathe, your saddle can cock over to another direction and it will change the diameter you're cutting. That is right on 3/4, right on the knocker. That's right on it, smack on. So that will have to do. I'd even argue that that is probably a couple of tenths under as well, which is pretty well exactly what we're looking for, 1/4 thou under. That means that our broaching guide, this is, what was this, a thou and a half under or something, this should go in easy. Like that. So I think we're in for a good fit. Okay, so I'll set up a parting tool now and we'll lop this one off.